Hello everyone, welcome to Study Zone. Today I am going to explain how to solve logical equivalences without using truth table. So we have seen the many laws inside the logical equivalences. So with the help of these laws, let us solve the problems one by one. So the first problem is, in the first example, that is P implies Q implies R is logically equivalent to P and Q implies R. So at first let us consider LHS, that is P implies Q implies R. Right. So P implies Q implies R. Here we already know that P implies Q is equals to not P or Q. Right. So let us consider this as P only and this one as Q. Okay, so P implies Q is not P or Q. So not P or this is Q. So not P or Q. And then here same thing, Q implies R, right? So Q implies R means not Q or R, which means here let us consider this as P and this as Q, which is equals to not P or Q, correct? So not Q or R. So now look at this, here there is not P, here there is R, not Q or R, here or, here or. Therefore associative law, which means A plus B plus C equals to A plus B plus C, correct? So we can write it as not P or not Q or R. So here when we apply De Morgan's law, what will happen? If it will, the negation symbol will come outside and this or will become and, which means here De Morgan's law, that is not P or not Q equals to not of P and Q. If it is not P and not Q, then it will be not of P and Q, P or Q. Okay, so here same thing. We are applying De Morgan's law for this, that is not of P and Q or R. Now look at the RHS side. Here in RHS side what we need? We need P and Q implies R, right? So look at this. We got this one. Now what we have to do? We have to remove this negation symbol and in the case of OR, we want to replace it with implication. So here look at this, P implies Q is not P or Q, right? So if we write it as not P or Q is equals to P implies Q. So here consider this as P and this as Q. So here it is not P or Q, which means P implies Q, correct, which means P and Q implies R, which is equals to RHS, which is equals to RHS. Therefore, these are logically equivalent. Okay, so these are the steps to solve the first question. So let's go through the second question. In the second example, the problem is P implies R and Q implies R is logically equivalent to P or Q which implies R. So here R is in small letter, right? So we can write it as P implies R and Q implies R, which is logically equivalent to P or Q which implies R. So let us consider LHS. So if we consider LHS, the first step is we have to solve the implication, right? So here in implication what will happen? In implication we have P implies Q which is equals to not P or Q, correct? Here there is P implies R which means not P or R, and Q implies R, same thing. P implies Q is not P or Q, here same thing, not Q or R. So it comes under implication. Then Here look at this, R and R have same symbol, which means here R also have OR symbol and here also there is OR symbol. So we can take this outside, which means we are going to do the associative law. So not P or not Q, here or R, correct? So here not P and not Q. So here in De Morgan's law, we can write it as not P and not Q as negation of P or Q, correct? So here the negation of P or Q or R. So here we need to have this, right? P or Q implies R. So to do this, again implication law, which means we are reversing this implication law. Here consider this as P and this as Q. So negation of P or Q, which will be equals to P implies Q, which means P or Q implies R. Hence LHS is equals to RHS. We can rewrite it as P or Q implies smaller, which is logical equivalence to P or Q, which implies small r. Hence the solution. Okay. So the third question is P implies Q implies P is logically equivalent to not P implies Q. So here first consider LHS part, that is P implies Q implies P. So here there is implication sign. So we know that we have to apply implication law, that is P implies Q. Here P implies Q is equals to not P or Q, correct? So not P or Q. So here I combine two steps. So Q implies P will be not Q or P. So in the next step, look at this. Here we have R and OR symbol, right? So we can apply associative law, that is A plus B can be written as B plus A, right? So not Q or P can be written as P or not Q. Here there is A plus B, here it is in the form of B plus A, okay? So since it is of the format, now look at this, since it is of the format of A plus B plus C, which means A plus B plus C can be written as A plus B plus C, right, under commutative law. So what we can write, not P or P bracket or not Q. So here let us take not P and or P, right? So here true or false will be 1 plus 0 is 1, so true. And then let us consider here not P is false and P is true. So 0 plus 1 will also be 1, that is true. So if we substitute any value in not P or Q, the result will be true. So true or not Q. So same thing. True or false will be equals to true. If I take true or true, then also it will be true. So anything that is added to true will be true. So our LHS is true. So here we didn't get the solution we want. So now let us consider RHS. So in RHS we have not P implies Q, right? So not P implies Q. Same thing, we are going to apply implication law. So here look carefully. Here we are going to apply implication law on this P implies Q. Here in the P place there is negation P. Right, here look at this. We have P implies Q, correct? Here what will happen? Not P or Q. But in this case we already have negation P. So it will become negation of negation P or P implies Q. Correct. So since we have negation P already, so what will happen? It will become negation of negation P or P implies Q. And then apply double negation law. You know about the double negation law, right? Here if it is not of not P, it will become P. So negation of negation P will be P or P implies Q. Again we have to apply this implication law, that is P or not P or Q. Now look at this, we have same symbol, which means A plus B plus C can be rewritten as A plus B plus C. So A plus B, that is P or not P or Q. So as we simplified here, the same thing, if we do like that, it will be true or Q. It is also same like this. So anything is added with the true, it will be true. So we have in our LHS true and in our RHS also true, which implies LHS is logically equivalent to RHS. Got it? So this is how we can use different laws to solve the logical equivalence. So in the next video, let us go through some other examples. Thank you.